Hi dears, welcome back to our basic science class. In the previous class, we started the 6th chapter and learned about some simple machines we use in our daily life, right? Now observe the children playing on seesaw. On the first seesaw, the bigger boy has easily lifted up the smaller child. You see the two children balancing each other on the second seesaw. Don't you see that the small child has easily lifted up the bigger boy on the third seesaw? We can find out why this happened observing the position of the child and the hinge on which the seesaw turns. In the first seesaw, the bigger boy is sitting near to the hinge on which the seesaw turns. But the smaller boy is sitting away from the hinge. In the second seesaw, two children sit at equal distance from the hinge on which the seesaw turns. In the third case, the smaller boy is sitting away from the hinge on which the seesaw turns. But the bigger boy is sitting near to the hinge. This is why the small boy can lift up the bigger boy. Okay? We use strong rods to lift heavy loads and thus reduce our effort. This is possible because the rod is free to move about a fixed point. So, levers are rigid rods that are free to turn about a fixed point. Levers are simple machines because they make our work easier. Can you lift 5 marbles using 1 marble? Let's do this activity. Materials required: a long ruler, 2 empty matchboxes, 6 marbles, a pencil and a double-sided gum tape. Make a seesaw as shown in the figure. Place the matchbox each on either side. Put a marble in one matchbox and 5 marbles in other. Slide the ruler over the pencil as required to maintain balance. Slide the ruler again to a position so as to lift 5 marbles with 1 marble. Here the ruler acts as a lever so that a greater weight can be lifted using a smaller weight. Now see the picture of a man lifting a big piece of rock with the help of a crowbar. Here the crowbar acts as a lever. It is because the crowbar turns about the small stone kept below it that the big stone gets lifted. The point about which a lever turns is called the fulcrum. So once again, what is fulcrum? The point about which a lever turns is called the fulcrum. Then where do we apply force? Yes, here. The force we apply is called effort. We represent it as E. So, what is effort? The force that we apply on the lever at a fixed point is known as effort. Now, where did we place the weight or load to be lifted by force? Yes, it is here. The resistive force that is overcome by the effort is called resistance. We represent it as R. So, once again, what is resistance? The resistive force that is overcome by the effort is called resistance. Now, let's recall the main points that we learned today as levers. Levers are rigid rods that are free to turn about a fixed point. Fulcrum. The point about which a lever turns is called the fulcrum. Effort. The force that we apply on the lever at a fixed point is known as effort. Last point, resistance. The resistive force that is overcome by the effort is called resistance. Okay, children, hope you all understood everything. Study well. See you in the next class. Thank you.